Hello students, today we will be discussing about Geographic Information System, or in other words GIS. What is GIS is all about? People say that it is a concept, a unique concept which has been devised by geographers. Geographers were inventors in one way, the concept of GIS. In fact, it was used more for mapping purposes. So, when they started using the maps, they thought that somewhere we will be in a position to understand and work with computers. So, once the advent of computers helped us to improve or impart or try to incorporate mapping through computers. So, that was the birth of your GIS, and in fact, people also call it as an assisted cartography. In fact, cartography, as all of you know, it is nothing but a science or the art of making map making. Well, when you come to GIS, they said why do not we extend the or use or utilize the services of a computer to work with GIS or to work or make a map using GIS. So, that is how the birth of GIS started. So, more of it is say that GIS is a extension of cartography or computer assisted cartography. So, this is how GIS started its entry into this world, and now as all of you know that GIS has become very powerful tool in various applications, especially wherever we try to handle or use say spatial data, that is data which has got reference to space. So, coming to the concept of GIS, we say that a general concept will give an idea how GIS is evolved, I just told you, and we can also understand or work with GIS, and for today we can just learn or work with GIS in detail about the concepts part of it. Well, so as I was just telling you about that, anything and everything on the earth's surface, we call it as an object. That is object in the sense right from an ordinary electric pole to an huge building. Everything on the earth's surface is an object, especially even if you consider say a hill, a mountain, everything is an object as far as GIS is concerned. So, we say that GIS is being used say for exclusively for decision making purposes. In fact, people started using it for map making initially. Now, it is more of a decision making tool, and wherever we use data or whenever it has got a reference to say a earth coordinate system, or we call it as it is in when it is in geographic form, we use GIS. What should we know, or please, what should we know about GIS? So, what exactly you should know about GIS, how GIS works. So, let us see, first thing is the components of GIS: geographic, information and system. Geographic, we say maps, that is dealing with maps. Information, we will just see the other details later, versus pertaining to data. Then the system, that is computerization of the entire aspect. So, we say GIS is a set of say geographic, information and the system. So, the three components of GIS is that we are working with in GIS rather. Now, coming to the system part of it, what exactly is a system? How does it work? Let us see that part. When we say system, we say a group of connected entities or activities which interact for a common purpose. In fact, we can call everything and anything on the earth's surface which is working together to achieve a specific goal is a system. For example, let me talk about our own system, nervous system, a computer system, a music system. Similarly, in this context, we are working with information system. So, when I say system, you know what system is all about. Now, we talk about information system. So, when I say information system, it is a process, as all of you know, it is a process executed with a purpose, and we normally work with say raw data, and ultimate aim to use or work with GIS is to produce information which will be useful in decision making, which I have been telling you right from the start. Well, when we talk about geographic information system, when we talk about information system, we said it is useful in say decision making. Similarly, when you are working with geographic information system, this particular aspect will have reference to a specific geographic location, or we call it as which has got reference to space. Whenever we are using information with reference to space, it forms say geographic information system. So, this is what about GIS, simple explanation of GIS in. So, let us see in detail what exactly what happens, or how does a GIS work, or how do you use GIS in various studies in our context. Now, coming back to the first point, namely talking about what does a GIS do. It invariably stores the data, in fact, it captures the data, which will be in various forms. It stores the data and it is capable of manipulating the data, and ultimately as any other system produces or gives you a say a result, or it gives a output. So, it is capable of system for storing, inputting, manipulating and getting the output in the form of map and any other output ultimately. Now, what does it do? How does it work with? Like any other system, we also say that GIS combines software with hardware, data and other general things whatever is used in a system. So, similarly here also we will be using hardware, software and the map data, and all of them are put together and the GIS system is formed. Ultimately, we say that GIS is a class of a software on its own. In fact, I want to make it very clear, GIS is not a science by itself, it is more of a software, it is more of a concept. So, only it is a concept, and that concept will be elaborating in the following talk. Well, coming to the next part of it, what is geographic information system? We have just seen the outline. Let us also see, as I was just telling you about that, whenever if you are acquiring information that has got reference to space, as I was just telling you, then that information can be called as say geographic information system. Well, when you talk about a simple example of a specific phenomena, rainfall which is occurring in an area, or a temperature in a given area. So, when I say rainfall, temperature, or for that matter even elevation of a particular point or a zone area, we call it as. So, these things are simple inputs into GIS. How does it work and how we are going to work about that? Ultimate aim of GIS is to see that it will be helping decision makers or planning purposes. So, that is the main aim of say GIS. Now, coming back to this particular point of say your rainfall data and all those things, we will see in detail, only then you will be in a position to understand what exactly the components of GIS are. First and the foremost is your data. What is data? So, people should know what exactly is data. Of course, it is not that we are trying to say what data is all about, but just to know what is data. It is nothing but collection of a detail about a specific phenomenon. In this context, I have just told you about collection of say for example, the rainfall details of a given point, or elevation of a given point, or a temperature in a given location, whatever it is that. So, collection of detail of a particular phenomenon is called as data. Now, what is information then? Information is slightly different, or it is different from data in the sense when we try to derive meaningful message from data, information is obtained. So, we say that when I am just telling you about the temperature of a given point or a location. So, when I say temperature, let me say today's temperature is 28 degrees, yesterday's temperature is 26 degrees. So, mere mentioning of the detail like temperature of today and yesterday, we just say it is nothing but your data. So, it is not information for your kind information other. So, we say that information here is obtained when we try to compare the data, manipulate the data, or work with the data, in analyze the data, we get information. So, when what is that I am trying to do now is now to compare the data. When I say comparing the data, I am trying to compare the temperature of yesterday and today. So, today's temperature is 28 degrees, yesterday was 26 degrees. So, what is the information we acquire from that? So, we say that yesterday was much cooler when compared to today. Now, again information, there are two components very important. We say that information could possibly be qualitative in nature or quantitative in nature. So, let me say qualitative information. In this context, we say that temperature was higher or lower. So, that is a qualitative information. We say that yesterday was cooler, today is hotter. This is just for example, it can be anything for that matter. Now, coming back to this, say we say quantitative information. To what extent or to what is the variation in the temperature. So, let me say yesterday was 26 degrees, today is 28 degrees, then the temperature variation is 2 degrees. That means quantitative information is nothing but the variation in temperature of yesterday and today. So, that is how we normally look at the information. So, we say that qualitative information and quantitative information. Please bear in mind GIS is more useful for tool of qualitative studies, but of late because of advent of various techniques and software development, we find that quantitative also quantitative analysis is also possible in GIS. So, that is a very effective tool in all aspects. Now, coming to the point of say spatial information, what exactly spatial information is all about? As I was just telling you, information about a specific geographic location. So, in the case of say when I was telling you about temperature at Connaught Place in New Delhi. So, let me just presume that is a place where we are trying to get the temperature. So, here we say the temperature was hotter today at Connaught Place in New Delhi, India. So, this is what is your spatial information. Then when you talk about a very important component, namely the attribute or the descriptive information, that is information which is attributing to the specific phenomenon. Here this phenomenon is a temperature and the place is Connaught Place, and we say temperature and we acquire or try to get the details about that particular place with various applications, for various applications we say that attribute data or attribute information. So, this attributes are nothing but the detail which we acquire or try to obtain about that particular point, and then attach the data to say your space, that is your point or wherever you call it as the region, whatever it is that. So, we say that most important thing is that spatially we say an object is present in a given terrain, and for that particular object, which can be anything for that matter, we will see the details later, anything for that matter, and the attributes are nothing but the details collected about that particular phenomena and then attaching that to say space. In fact, GIS is a very unique concept where we say that when we are trying to look at objects in any other context, it will be more of a say, dead object, whereas in GIS it is active one, in the sense you find a particular point which could be anything for that matter. I just told you about electric pole to a huge mountain. So, for the electric pole we can try to get information or details about that particular object and then attach that to that. So, that is what is your spatial data which is connected or attached to say a specific object, and that is your attribute information. And the next point is your time factor. We say that time actually varies when over a period of time what happens to the data. For example, let me say today this particular building was existing here, but incidentally after a couple of days this might be demolished. So, we say also that over a period of time data or information changes or the spatial objects might change basically, but whatever is present at a given place, it is at that particular place, it will never change. The position of the objects will never change. Only thing is that the object may be changed in terms of because of something like, as I told you, when I try to demolish a building which is existing for the present day, may not be there tomorrow because of the demolition. So, that is one particular say over a period of time there is a variation in also in spatial objects. Now, here I was telling you about the spatial information which again pertains to say location and shape of geographic features and their spatial relation to other features. A very important concept in GIS, we will see little later. Let me say, how do you represent objects? I was just telling you objects right from the beginning. When I say objects, when I talk about objects on the earth's surface, these objects have to be represented on a sheet of paper so that I can bring it into a system. In this context, how do you represent objects on the earth's surface? Whatever may be the kind of object, we have the three types or the features we call it is in GIS in general. The feature of point data, line data and area data. So, point feature, line feature or area feature. So, this is what is actually the basic requirement or the basic input one can make into GIS system. So, this is how we normally work with it. Now, coming back to the point data, let me come to that and let me explain you one simple example. What is a point data? In the context of the world, we say that a point is nothing but represented as a coordinate x comma y. That x comma y could be anything for that matter, anywhere, anything on the earth's surface can be represented as a point. But again, make it a point that there is no object on the earth's surface which is a point in nature, because all the objects have got, even if I am going to prick a point with a pin on the surface of the earth, that contains something like say the radius and the diameter, even maybe micron level. Hence, basically there is no object in the earth's surface which is supposed to be point in nature, but still for representation purposes, for the purpose of utilizing the data, for purpose of using the data on some other on various occasions, we use that, we say that point data, line data, area data. Let me give an example for each of them. For example, when you talk about point data, I was just telling you right from the beginning, a electric pole, a temple, in the context of electric pole and temple, when you just try to compare, electric pole, as you can say, we can call it as a point, because not going to be an issue. Even if it is going to be a post box, it is going to be a point. But when you come to terms of say your a temple cannot be a point, because it is a huge area. Some of the temples are as big as 10 to 15 acres in size. But still, for representation sake, we are not going to use that as an area, we are going to use it as a point data. Now, coming to the line point, a feature which is indicative in terms of say line. Line is nothing but, as all of you know, it can be represented connecting 2 points. Of course, when I am just trying to extend 2 points, beyond that it may become a curved line, or it may be a line which is bent. But basically, a line is a culmination of joining of 2 points minimum, and more than that, of course, above that also you can also have any number of points and then complete a line which will be running from one place to another place. For example, a simple example of that is your river body. A river body can be represented as a line, can be represented as an area. Let us see area little later. Let me say that when I talk about river body, a river body can be represented as a line, in the sense a center of the river body can be drawn as a line and then call it as a say line. Similarly, a road network. A road, we can also have the center of the road as a line and then utilize. In fact, there is a huge and a massive application of your line data in various applications as far as your resources flow is concerned, that we will see at later stages. Now, initially you should know what is a line. Line is nothing but joining of 2 points, and then we just complete a circle of that. It may not be an area, it may be a closed line, but it is not an area. You can just have n number of points, x, y coordinates will be there. So, in the context of your GIS, we use line according to the requirement, and of course, as I just told you right from the beginning, that you will not have any object on the Earth's surface which is just a point or a line. Everything is an area. Area in the sense, when I talk about point, it does not have either your area nor your length. When I talk about line, it does not have area, it just has length. But when I talk about area, it has got both the length as well as your area. That is perimeter in the terms of your object which is there. So, all objects I just told you, everything is an area as far as the Earth is concerned, but for GIS and for our applications, just for us to have an idea what exactly is present where, we can use or call an object which can be a point, can also be an area can be also be called as a point. For example, I told you about temple, a temple which is actually aerial in extent, but it is represented as a point. But when you are trying to work with a temple and its area and its calculation, then you will have to use the temple as an area, but not as a point. So, this one basic thing you should bear in mind. So, point, line, area, any object which is present on the surface can be represented on a sheet of paper. To prepare a map, we call it as a point, line, area. This is the only way in which you can represent the objects. No other method you can use that. Well, of course, we talk about the data. Now, when you just come to the point of data, I said point, line, area, and what type of data is that? So, that data wherein which we use point, line and data, we say there it is vector data. That means, it has got both direction and magnitude. So, when you in the line part of point, it is only your say direction will be there. When you talk about the magnitude, a line will be having magnitude, in the sense it will be moving in a specific direction, and it also got a length of it. So, this is what is the basic thing what you have to bear in mind. Representing objects could be point, line, area. So, as it is a very important aspect, I thought I could just spend a few more minutes on that. Now, coming to the next part, I was just telling you about how you can represent the objects. As you can see on the slide part of it, how the objects are shown. Here, let me say a river as a line. I was just telling you about how a river is shown as a line. This is an indication of a drainage. This also could be a drainage, this could be a stream, whatever it is that, it is a river part, and the center line of that particular river is shown here as a line here. Of course, you can also show river as a aerial object. Then talking about your point data. As I was telling you about point data, for example, a lamp post or electric post or whatever it is that, and when you talk about the point data represented in a small scale data, for example, when I am talking about data being represented, say or a settlement being represented in a small scale map, especially say a map in a sense a topographic map. Topographic sheet, you must have heard about that. This topographic map will contain settlements which will be normally in the scale of 1:50,000 or 1:25,000. So, the smaller the scale, the larger the objects will be appearing as small, naturally, isn't it? So, when you talk about a 50,000 scale, that means 1 centimeter on ground is equal, on a map is equal to your 50,000 units on the ground. So, 1 centimeter is equal to 50,000 centimeters on the ground. So, that is one basic thing you will have to remember. So, when you talk about a map or a topographic map, when you want to represent a small hamlet or a village, so that has to be represented only as a point, you cannot show it as a area. Hence, settlements normally shown as point if it is going to be shown in a topographic map. But the same settlement, if it is going to be analyzed, if it is going to be worked with, or you are going to work with say various individual buildings, then you cannot show settlement as a point. You will have to show it only as a say aerial object. The line data, which we can also show in the form of say a closed line, which need not necessarily be an area, a closed line here, that is your administrative units. Like say some example, people talk about tahsils, they talk about the districts, and then your state, and then the country or the nation rather. So, we can show the aerial objects also in the form of a closed line, but not actually area. But when you want to make a area or make calculations, you have to show this line as a closed one, and it should be area in nature. Only then you will be in a position to find out the aerial extent or calculate the area of that particular object. Now, finally, very important thing is that representing the objects on from say ground surface onto the map part of it. Now, where are we now? The very important thing you have to remember is that when I am working with say a map, there should be a difference between a drawing and a map. Most of the people have a general tendency to feel that maps or drawings are nothing but extension of maps. It is not exactly. There is a major difference between a drawing and a map. So, let me start with, let me explain you what a drawing is all about. So, as all of you know that as an architecture or a civil engineer or a geologist or a geographer, we use drawings for various purposes. For example, when I am trying to survey the land with the help of your say total station, I try to use a line data, and then I represent that as a drawing. Now, invariably drawing is referred to a specific, say we call it as a non-earth coordinate system. Drawings are non-earth coordinate system. Then people also say that drawings are north oriented. Yes, drawings are north oriented. It is also to scale, but the major difference between a drawing and a map is that a map is earth coordinate system or referred to earth coordinate system, whereas a drawing is a non-earth coordinate system. In other words, simple words, we say that if a drawing is referred to a specific geographic coordinate system, it becomes a map. So, there is a major difference between a drawing and a map. Without a proper scale, many people have a general feeling that drawings do not have scale. I am not talking about freehand drawing, I am talking of drawings which are drawn with a purpose. So, these drawings do have a proper scale, and they are also oriented towards north, but they are referred to a specific coordinate system, namely your non-earth coordinate system, or you call it as a rectangular coordinate system, or you talk about the Cartesian coordinate system, all these things. But when you come or you talk about or you discuss about say a map will never be say non-earth coordinate system, otherwise it will not become a map. A map is map is nothing but representation of the various objects on the earth's surface in a earth coordinate system. In fact, the most popular one is your latitude and longitude. As you can just see from the slide, you have the grid or the reference grid of that object what we are trying to use, that is your latitude and longitude. And I need not necessarily tell you what latitude is all about and what longitude is all about. We also have another unique method of representing this data, namely using a reference of say your UTM, Universal Transverse Mercator System. So, where we use instead of using this latitude longitude, we use what we call as the meter, that is your northing and easting. The same context, latitude and longitude are replaced by northing and easting, and they are in the form of say your meters, whereas the latitude longitude is in degrees. So, we call it as the degrees, minutes and seconds, DMS, or it will be DD or your decimal degrees. This is the way we normally represent your latitude and longitude. So, as I was just telling you, the objects can be represented as a point, line, area, and that has to have a specific reference to a specific coordinate system. Only then a drawing becomes a map. So, this is all the difference between a drawing and a map. Now, coming to the attribute information. When I talk about attribute information, I was just telling you in the beginning, when we try to acquire or get some detail about a specific phenomena. When I am trying to get a detail about a phenomena, namely it could be, as I was just telling you, about a temple, or it could be an electric post. When I talk about an electric post, let me start with a simple example. Electric post. What does an electric post contain? Normally we say that it may be made out of. So, what is the material it is made with? Rather, so let me say it could be concrete, it could be electrical, I mean your steel, or whatever is that. So, or sometimes in those days it was aluminum. Nowadays it is not possible because it is a very expensive thing. Now, anything and everything which is in the form of an electric pole, we can get its type of material it is made, what is the height of it, what is the diameter of it if it is circular, what is the width if it is going to be rectangular, or the length and the breadth if it is going to be regular, things, all these details. Apart from that, what is the height of it? So, if I know the height of it, then I will also try to say if it is an electrical post used only for power supply, then we will know how many lines are connected to that pole. Descriptive information, I was just talking to you about an object which in turn has various elements. Descriptive information could contain elements which should not be compared with each other. Please bear in mind, we should not compare the data either in terms of quality or quantity. For example, when I talk about descriptive information about a plot of land, as a student you will be interested in knowing what exactly is present in a piece of land. So, that particular land may contain a building which is built up. So, a open land which may contain a building, and that building may be of various shapes depending upon the way in which it is constructed. It could be a simple rectangle, it could be a square, or it could be any other shape, which is a very unique thing of a particular building. Now, when you are coming to the particular building, we talk about say its detail. What is that we can get about that particular plot of land or piece of building? We say a property ID. So, ID given to that particular property. So, we have property ID number. Then we can also obtain say the owner's name, getting a owner's name. And then very important, if you are talking about any other detail in the surrounding, what is the kind of vegetation you have in the surrounding area, what kind of vegetation is there, what is that zone it belongs to, because just an example, it could be anything for that matter. So, attribute information is nothing but getting a detail about a specific object and then attaching them in your GIS. So, that is what is your attribute information. As I was just telling you initially, over a period of time there is always a variation in a given terrain. Invariably, when you talk about the hills and the mountains and the other resources, natural resources, there will not be much of variation. When you talk about infrastructure, what is present today may not be present in the following day. It may be demolished or it may be remodified and things like that. Hence, over a period of time we presume that over a period of time that there will be a variation in geographic information. Hence, we should be knowing that or consider time also as a factor in GIS. Yes, I was just telling you about the attribute data, what kind of attribute data it could be there. For example, let me start with just a simple example, census data which is normally collected by say the administrative staff or the municipalities or extent of area. Land parcel ownership records. So, these are some of the examples. Let me talk about soil or vegetation characteristics in a given area. I was just telling you about the natural resources. Health records which are normally collected by say the medical center, or road quality information which is derived by the road departments. So, these are simple examples of attribute data. Using it in particular in GIS, we collect the data from the ground or from any other source and then attach that with your GIS. Now, what kind of hardware people use in GIS? Of course, just like any other system, there is nothing like unique or exclusive in this. A simple GIS software which runs on any kind of hardware, which will have also its own peripherals. So, the peripherals are invariably printers, plotters, scanners, monitors, and invariably it has to have a network and also your wide area communication. I am just trying, because all these things are very well known to every individual. I just personally feel that there are certain things which are very important for utilizing in GIS. For example, scanners. So, these are the important inputs, or we call it as a peripheral in a GIS environment, which will be of immense use when you are trying to input the data from another environment. So, we use these scanners for scanning the maps or scanning any other drawings and then inputting into GIS. Let us see the details little later. As I was just telling you that we have various hardwares which are available, or GIS runs in various hardware types, but nowadays, because of the advent of GIS, we say that centralized computer servers to a simple desktop computer. Anywhere, everywhere it runs. But of course, it is not that all GIS software runs in all environments, but the most important thing is that a desktop GIS cannot be used in a server. We require a server based GIS software. So, it is not only it works in standalone machines, it also works in your massive or huge server or network system. In fact, all over the world people use it for various purposes. One simple example is that tracking your own say people, you know all of you are using smartphones, and everybody are having a GPS installed in that, and it is we are sending the data from your smartphone through GPS to internet. So, in such cases we use server based GIS software to know where I am, where all these details are obtained from that. Now, coming to the GIS software, the very important one, let me give you detail or how we normally work with GIS. For any GIS software, what is important or what is the input we require is that data input and verification, that is capturing of the data. In the initial first stage itself, I told you, when you try to use GIS, we try to capture the data. So, we input the data, we verify the data. Why should we verify the data? The question arises here, why somebody should verify the data. So, when I say verifying the data, we normally presume that the data what we obtain may not be of the latest date. Hence, verification of the data plays an important role in GIS. So, it also depends on your application. When I am trying to understand what is present in a given terrain or given area, for example, a small town or a city, where in which I may have about 600 or 700 parcel of lands and then about 2000, 3000 inhabitants in that particular place, I should know, I should try to use the data which is of latest date. I cannot use a 2003 or 2005 data. I will have to use at least 2013, 14 to analyze and work with that. So, data verification plays an important role. Age of the data is one, and the quality of the data. Next thing is, in the same context, verification I was just trying what I was trying to explain you is that you have to know the quality of the data what I am using it. For example, I can't use a map which is a very old age or very old one which is also in crumbling stage. All these things you have to take care. See that the data what you obtain from various sources is of high quality. At least you are in a position to scan the data and then input into the system. So, data input and verification forms the most important part in GIS. Then the next important thing is your data storage. How do you store the data? How do you retrieve the data, and how do you manage the data? Data storage is a huge science. In fact, computerization or computers play an important role here. Software development, all these things are there wherein which we try to understand how the data is stored. I was just telling you in the initial stages, first and the foremost method of storing the data is in the form of a vector data which is in vector form. Of course, we can also use data in raster form. Please do not get confused with your vector data, raster image. Raster data and raster images are different. Raster images we will see little later. So, you should know that GIS data can be in the form of either vector or in the form of your raster. Both of them are used for various applications, and different depending upon the application we will be using whichever data is important. But the most important thing is that to save space, the importance here lies in your how do you retrieve the data, how do you store the data, how do you retrieve the data. So, data retrieval, the best method of storage will also help you in retrieving the data. Similarly, management of the data. So, but it is a very important thing, but as an application scientist or an application engineer, you need not bother about how the data is stored, retrieved and managed. That is all done by computer professionals. We are more interested in knowing what type of data we are using, how it is stored in a GIS environment. So, that is the second aspect. The third aspect is that, and very purpose of that. In fact, you should bear in mind that any kind of data what we use, if it is going to be a hard copy, what is the point in using a data which is in hard copy? There is no use at all, isn't it? So, what we have to do is that we will have to use the data with a purpose. Instead of having it in a hard copy, we are going to convert it into your say soft copy with the first step, data input. And then we are going to store the data using your simple method. So, simply when you just ask the system to store it in whichever format you want, that will be storing. But the ultimate aim in GIS is that to manipulate the data, analyze the data. So, when I am saying manipulation of data, analysis of data, this is where the role of GIS software comes into play. Now, every software, there are about 100 different types of software which is there on the earth surface when in your globe, but the most important thing is that which software has to be used in at which place. This is where the role of an engineer or a scientist play. We have to decide what software you have to use. For example, if I am going to just capture the data, there is no point in using high end software because it is a very expensive software. When I am trying to use the data just for the sake of storing, we go for a low end. When I am trying to use the same data after storing the data, what am I going to do with the data? Let me say, for example, I am going to analyze the data. When I am going to analyze the data, I have to have a facility in the software, otherwise it will not be useful. Hence, you have to decide based on the application, based on the study, whether the data is going to be used further or is only going to be conversion. So, it is a digitalization, just simply digitize the data and store it. There is no need of any high end software, you can go for a low end software. And finally, once I analyze the data and I also use for modeling purposes, there are a lot of applications now using GIS. Once that part is over, we go for finally say data output. So, ultimately, isn't it, for any kind of study, anything we do, output is an important thing. So, we will have to generate a product from that and ultimately make a presentation. So, the data output and presentation forms the last part of GIS. So, the 3 or 4 modules which are important in GIS is that invariably low end software will have a facility to input the data, store the data and then present the data. Relatively moderate or high end software will have a facility also to analyze and also manipulate the data, ultimately generate or work on various models. So, this is what are the 3 or 4 components in a GIS environment. We call it as the GIS software. It consists in a GIS software, these are all important. Thank you.